Okay, I want to continue with the sheet called Examples of Hypotheses Requiring One-Way ANOVA or F-Tests to Test. I'm now going to examine example of hypotheses for ANOVA number 3. This is what that sheet looks like. Hopefully you have it by now. And we're right here where my index finger is on my right hand. We're on the third of 5 examples. H sub 1. H sub 1. Republicans, Democrats, Greens, Libertarians, Socialists, Communists, and Fascists turn out for elections at significantly different rates. So the research hypothesis or the alternative hypothesis, research/alternative hypothesis is stating that those 7 groups are going to be different from one another regarding the rate at which they turn out for elections. The null hypothesis, H sub 0, Republicans, Democrats, Greens, Libertarians, Socialists, Communists, and Fascists turn out for elections at equal or the same rates. And again, note, these 7 groups, in this case, groups are defined by the political party they belong to, are being compared regarding the rate at which they turn out for elections. Now, I want to pause for a minute and just note, the reason we need to put these groups, or put the differences to the test, as it were, the statistical test, as it were, is because just due to sampling error alone, we would anticipate there to be differences. So that principle is exactly the same as what we discussed back when we were talking about t-test for 1 sample and t-test for 2 samples. Due to sampling error, right, and we have seven groups here, 7 groups. Republicans, Democrats, Greens, Libertarians, Socialists, Communists, and Fascists, 7 groups. Based on sampling error alone, we would expect there to be differences between those groups. However, what we want to test via a one-way ANOVA is whether or not the amount of difference we observe can be attributed to chance or sampling error alone. Now, if that language sounds familiar, it should, because that's exactly the same language and it's really the same principle involved when we were conducting t-tests for 2 samples, except now we're comparing more than 2 groups. So again, note, for this example number 3, note that those 7 groups, in this case, groups are defined by the political party they belong to, are being compared regarding a quantitative variable. Those 7 groups, those 7 samples are being compared regarding a quantitative variable. And in this case, the quantitative variable is the rate at which they turn out for elections. Example of hypotheses for ANOVA number 4, H sub 1, the research/alternative hypothesis, H sub 1. Assembly line workers, commercial meat processors, and trash removal workers will have significantly different rates of on-the-job injury. H sub 0, the null hypothesis, the hypothesis of equality. Assembly line workers, commercial meat processors, and trash removal workers will have, I have a typo there, my apologies, will have the same or equal rates of on-the-job injury. So again, we have 3 groups. In this case, groups are being defined as the sector within which they work, are being compared regarding a quantitative variable, in this case, rates of on-the-job injury. Example of hypotheses for ANOVA number 5, H sub 1, the research or alternative hypothesis. People who work for nonprofit organizations, that's group 1, people who work for for-profit organizations, group 2, and government workers, group 3, have significantly different rates of depression. So 3 groups being compared across, according to these hypotheses, 3 groups being compared across some quantitative measure of depression. H sub 0, the null hypothesis, the hypothesis of equality. People who work for nonprofit organizations, people who work for for-profit organizations, and government workers will have the same or equal rates of depression. And again, note, 3 groups, in this case groups are defined as the type of agency they work for, are being compared regarding their rates of depression. And again, I just want to note that Due to sampling error alone, we would expect there to be differences between those 3 groups, or those 7 groups, or those 4 groups, or those 5 groups. Due to sampling error alone, we would expect there to be differences between those groups. However, what we need to find out via an F-test, putting those differences to the test, we need to find out whether or not the amount of difference we observe between those groups as a whole, we need to find out whether or not the amount of difference can be reasonably attributable to chance or sampling error alone.